All right, this is Unit 6, Lesson 3, the Pythagorean Theorem and its converse. So I want to start by reviewing the distance formula. We talked about this earlier in the year, but I do want to review it because the Pythagorean Theorem and the distance formula are related, okay? They go together. So again, the distance formula, the distance d between 2 points, x1, y1, and x2, y2, is given by the following formula. Okay, the distance d equals the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, that's the distance formula. So find the distance between 7, 5 and 1, negative 7. So I'll do, we're going to give our answer in simplest radical form. And we'll give it as a decimal. We'll do it both ways. Okay, so I'll do 7 minus 1 squared. If I do 7 minus 1, then I have to do 5 minus negative 7. Seven minus 1 is 6. Five minus negative 7, if you want to make that plus a positive, it'll be plus 12 squared. So 36 plus 144. Go slow through this, one step at a time. So that equals 180. Let me get my list of perfect square numbers out. All right, so we have to simplify the square root of 180, and these are my list of perfect square numbers. Which is the biggest number on this list? That's a factor of 180. Pause the video if you need to and do it on your own. But the answer is going to be 36. So when I simplify 180, I will use the square root of 36 times the square root of 5. And so if I say give your answer in simplest radical form, or if I say give an exact answer, the answer will be 6 square root of 5. That is the exact answer. That is simplest radical form. If I said give your answer as a decimal, that would be, let's do approximately 13.4, I'll call it. Okay, so the Pythagorean theorem comes from the distance formula. In a right triangle, the sum of the squares of the length of the legs is equal to the square of the length of the hypotenuse. Most of you know that as a squared plus b squared equals c squared. I don't like saying that because what does the a, b, and c even mean? The real way to think about it is a leg squared plus the other leg squared equals the hypotenuse squared. That's the Pythagorean theorem. Leg squared plus leg squared equals hypotenuse squared. Okay. Now, you've seen that before? Okay, you've seen that plenty of times. We're going to do some examples with that. We're going to do some hard ones. But before we do that, I want to prove that theorem. I want to prove the Pythagorean theorem. So we have triangle ABC with right angle C. We are going to prove that a squared, one leg squared, plus the other leg squared equals the hypotenuse squared. Okay, so here's how we're going to do it. Remember the geometric mean lesson yesterday? I'm going to start by doing something with the geometric mean. Okay. A is a leg. So the leg A is the geometric mean between the part of the hypotenuse right next to it, in this case y, and the entire hypotenuse C. And B is another leg, and that is the geometric mean between the hypotenuse part right next to it. Do it over here. B is the geometric mean between the part of the hypotenuse right next to it, x, and the entire hypotenuse C. Let's cross multiply. A squared equals C times y. Cross multiply here. B squared, okay, B times B, B squared equals C times x. Now what I'm going to do is I'm going to use the addition property of equality. Since these are equal, a squared equals cy and b squared equals cx, I'm going to add a squared plus b squared together. And I'm going to add cy plus cx together. Okay? Now I'm going to factor out the c. So I'll have a squared plus b squared equals c times y plus x. And check this out. Y plus x, y plus x, y plus x, y plus x. That's the same thing as c. The entire segment is c. C equals y plus x. So let me replace y plus x with c. Substitution property. And c times c is c squared. So that's a proof of the Pythagorean theorem. There are more proofs. There's different ways you can prove this theorem. But I just wanted to show you one way related to what we did yesterday. So you can see a squared plus b squared equals c squared. In other words, one leg squared plus the other leg squared equals the hypotenuse squared. One more definition for right now. A Pythagorean triple is a set of non-zero whole numbers, a, b, and c, that satisfy the equation a squared plus b squared equals c squared. In other words, 3, 4, 5 is Pythagorean triple because 3 squared plus 4 squared equals 5 squared. Okay, 5, 12, 13 is a common Pythagorean triple because 5 squared plus 12 squared equals 13 squared. You should try to memorize these. I think everybody has 3, 4, 5 memorized probably. But if you could memorize these, it'd be good. Okay, those are common Pythagorean triples. Example 3, find the value of x. Write your answer in simplest radical form. Just be careful when you set up your original equation. It's going to be leg squared plus leg squared equals hypotenuse squared. So it's going to be 16 squared plus 30 squared equals x squared because x is the hypotenuse. Make sure you do leg squared plus leg squared equals hypotenuse squared. So this will be 256 plus 900. It'll be 1156. To solve for x, take the square root of each side. If this was algebra 1 or algebra 2, you would take the positive and negative square root. But since we're in geometry and we're doing the distance, we're only going to do a positive square root. Now, one thing you should do is check and see if this is a perfect square before you even look at your list of perfect square numbers. In other words, do the square root of 1156 in your calculator and see what you get. It's exactly 34. So you don't have to do anything with the perfect square number list because this answer is just 34. And remember, the hypotenuse is the longest side. So you should have known ahead of time your answer was going to be bigger than 30. And it is. It's 34. So that one was solving for the hypotenuse. Now let's do a problem where we solve for the leg. Okay, you're solving for the leg this time. Write your answer in simplest radical form if necessary. So leg squared plus leg squared equals hypotenuse squared. X squared plus 4 squared equals 12 squared. X squared plus 16 equals 144. X squared equals 128. Means x is going to equal the square root of 128. And you're going to have to simplify that using your list of perfect square numbers, because 128 is not a perfect square like we had in example 3. So again, pause the video if you need to do this on your own. But it's going to be 64. X equals square root of 64 times square root of 2. And just be careful. A lot of times people will simplify the square root of 64 and they'll put it equals the square root of 8. That's not true. The square root of 64 is just plain old 8. Okay? So remember, the converse is when you switch the hypothesis and the conclusion around. So we have the Pythagorean theorem, and the converse is also true. Okay? So the Pythagorean theorem, if you have a right triangle, then you know the leg squared plus the other leg squared equals the hypotenuse squared. The converse is true. Okay? If you know the square of the length of one side of a triangle is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So what you're going to do, example 5, is this triangle a right triangle? What you're going to do is you're going to take the two smallest sides. Has to be the two smallest sides. In this case, 8 and 15. You're going to square them and add them together. Again, you're picking the two smallest sides. So 64 plus 225. That equals 289. Okay, and then maybe like off to the side somewhere, take the biggest side and square that. So the biggest side is 17. So off to the side, let's do 17 squared. And that equals 289. Since they both came in the same number, it means the answer is yes. So yes, the triangle is a right triangle. If I ask you a question like this on the quiz, you have to show out your work. Don't just say yes or no. You should always show out your work anyway in quizzes. Okay, let's do another one. Same type of problem. Is the triangle below a right triangle? So take the two smallest sides, has to be the two smallest sides, 19 and 20. Square those and add them together. 19 squared plus 20 squared. So that's 361 plus 400. 761. Then take the biggest side of the triangle, in this case 28, square that. Gives you 784, I think. Yes. So these are not equal, so the answer is no. Okay, so 761 is not equal to 784. So no, the triangle is not a right triangle. Okay, one more page. All right. Classifying triangles as acute, right, or obtuse. So the first one is easy. If one short side squared plus the other short side squared equals the longest side squared, then it's a right triangle. I think we just talked about that. That's the easy one. The next two, if a short side squared plus another short side squared is greater than the longest side squared, then it is an acute triangle. And if a short side squared plus another short side squared is less than the longest side squared, then it is an obtuse triangle. Okay, so example 7, classify the triangle whose lengths are 6, 11, and 14 as acute, right, or obtuse. Okay, so you're going to take the two shortest sides, in this case 6 and 11. Be careful because it's not always in order. Okay, so you could have the biggest side listed first, remember. Take the two shortest sides, square them, and add them together. So 6 squared plus 11 squared, 36 plus 121, 157. And then off to the side, take the biggest side and square that, 14 squared. Should have them memorized because I had you memorize the perfect cubes, perfect squares up to 225. So 196. Okay. And off to the side, I'm going to say 157 is less than 196. So let's see which one it is above. It's the bottom one. So I'm going to say the triangle is obtuse. Last example, you probably know this answer ahead of time because we just did an obtuse triangle and the previous pages were right triangles, so you probably know the answer, but we're going to do the two shortest sides squared, added together. So in this case, 7 squared plus 8 squared. That's 49 plus 64. Which is 113. Then off to the side, let's do the biggest side squared. In this case, 9 squared is 81. Okay, 113 is greater than 81. Let's go check what the answer is above. It's the middle one. Short side squared plus short side squared is greater than the longest side squared, and it is an acute triangle. So I'll say the triangle is acute. All right, so again, you have to make sure you know the Pythagorean Theorem. You have to make sure you know the converse. And you really want to make sure you have your list of perfect square numbers memorized. We did that in lesson 1. We also used that in lesson 2. And you're going to need it for this lesson, as you saw, and you're going to need it going forward.